Hello there! In today's video, I am going to model a very simple mechanical part using a True CAD workflow inside Blender. The exercise is inspired by a video by Yasser Alzein, but I will use it as an opportunity to introduce two important things. First, this video will be the starting point of a new series called True CAD in Blender, where I will model mechanical parts with increasing difficulty. We will start with very simple parts like this one and gradually move toward more complex pieces. Second, in this video, I will introduce something that was missing in my previous tutorials: drafting. In other words, creating a two-dimensional technical drawing from a three-dimensional model. Because let us be honest, what is CAD without technical drawings? It is like building a machine and then forgetting to tell people how to build it again. In this case, the workflow is still a bit experimental and not perfect yet, but it already works surprisingly well, and in my opinion, it deserves some attention. So if you find this interesting, spread the word, because this workflow really deserves a bit more love. And who knows, maybe one day Blender will surprise us with even better tools for this kind of work. Alright, enough talking. Let's start modeling. In this section, I will not comment step by step, because on this channel you can already find several tutorials explaining the workflow in detail. If you are new, you will find in the comments a link to a video that explains how to install Sverchok, which is a free add-on that I use in this workflow. You will also find another video explaining what CAD modeling, also called solid modeling, actually means and why it is important that Blender improves in this area. So if some parts feel a bit fast, do not worry. Those videos will guide you through the fundamentals. For everyone else, this part should be quite familiar. We start from a simple primitives and progressively build the solid using parametric operations. Extrusions, Boolean operations, and edge control allow us to keep the geometry clean and predictable. One of the main ideas behind this workflow is that the geometry is always driven by well-defined edges and surfaces instead of uncontrolled mesh editing. This keeps the model stable and makes later modifications much easier. Another nice side effect is that the model remains extremely light, which is something mechanical workflows really benefit from. If you ever open a heavy CAD file, you know what I mean. Sometimes even rotating the view becomes a small engineering challenge. Here things stay nice and responsive, and that is always a good sign. While the modeling continues, this is probably a good moment to relax a bit and simply watch the process. Procedural modeling can actually be quite satisfying to watch, almost like digital woodworking, except there is less sawdust and fewer chances of losing a finger. So we continue refining the geometry, making sure that edges stay clean and surfaces behave exactly as expected. At this point, the part is basically complete, which means we can finally move to the interesting part of this video, turning this model into an actual technical drawing. Now, the new part starts. As you can see, as I often do, I use a solid edge node to extract all the edges of the solid. These edges basically represent the skeleton of the object, which is exactly what we need for a technical drawing. Then I feed those edges into a node called path SVG set in curve mode. This converts the geometry into vector curves that can be exported as an SVG document. After that, I connect everything to an SVG document node, which generates the final file. If you prefer, you can build almost the same workflow using a DXF document node. Both formats are widely used in CAD environments, so you can choose the one that best fits your workflow. One very useful feature is that we can preview the document size directly inside the node setup. This means we can already think about the layout of the technical drawing before exporting the file, which is something that traditional CAD users will immediately recognize. So what I am doing here is simply positioning the object 3 times in the document space. Each copy represents one projection of the part. For example, the front view, the top view, and the isometric view. Nothing very fancy yet, just the classic orthographic projections, but already enough to build a proper technical drawing. Once you start thinking in this way, a lot of interesting possibilities open up. You can create sections. You can add detailed views. You can isolate specific parts of the geometry. And with a bit more work, you can even start adding dimensions, which is probably the moment when mechanical engineers start feeling more comfortable. Because without dimensions, a technical drawing is basically modern art. Nice to look at, but not very useful for manufacturing. So this small node setup is actually doing something quite powerful. It transforms the geometric information of the model into a structured vector representation. And that is exactly what drafting workflows need. If you would like a more detailed video dedicated entirely to drafting inside Blender, write it in the comments. I would be very happy to explore this topic further, because in my opinion this is one of the missing pieces that could make Blender even more interesting for technical modeling. Alright, the drawing is ready. Now let's move to the final step. In this last part I will go very quickly because it is mostly a matter of adjusting the drawing inside of vector software. My choice is Inkscape. Of course, because if you are already using Blender, it would be a bit strange not to appreciate another open source tool. Inside the vector editor, we can refine the line thickness, adjust the layout, and add titles or annotations if needed. Nothing particularly complicated, just a bit of visual polishing. And after a few small adjustments, we end up with a perfectly usable technical drawing, which honestly still feels a little bit magical considering where we started. So with this video, I think I have shown that a complete True CAD workflow can actually be replicated inside Blender. Modeling, edge extraction, vector export, and final technical drawing, all inside a fully open source pipeline, which is pretty amazing if you think about it. But now, I am curious to hear your opinion. Do you think something important is still missing? Do you agree with this workflow, or would you approach it in a different way? Let me know in the comments because I really enjoy reading your ideas and suggestions. And if you like this kind of content, please subscribe, hit the like button, and enable notifications. It is just a small click for you, but it helps the channel a lot. Seriously, you click a button and the algorithm smiles for 5 minutes. Everybody wins. Thanks for watching and see you in the next video. Bye.